Hello and welcome to Bits and Geeks, the UCL Data Science Society's podcast. I'm Dad, demystifying the hype around data science, sharing with you some of the latest developments in this exciting field, and giving you a head start to a career in data science. I'm Grace, a first-year master's student studying knowledge, information, and data science. And I'm your moderator for this podcast today. So our main host, Hamna, can you please introduce yourself?
Yeah, thank you, Grace. I'm Hamna. I'm a first-year undergrad student studying social sciences with data science, and I'm going to be your main host for today. So in this episode, we will be talking to Clementine Domine, having graduated from University of Manchester with a degree in physics and theoretical physics in 2020. Clementine joined UCL to pursue her PhD in theoretical neuroscience and machine learning. Clementine, welcome. Could you please tell us a bit more about yourself and your educational background?
Yeah, hi. Thank you very much for hosting me. So I'm Clementine Domine. I'm originally from France. I grew up in a very small village in the Alps next to Switzerland. And I went to do my undergrad in physics, as you just mentioned, at the University of Manchester, with theoretical physics. But even then, when making that decision, I already had neuroscience in mind. I was very much hesitating between doing a major in neuroscience and physics. And I kind of realized that physics would keep more door open and allow me to also have an approach that's much more analytical towards neuroscience, which is something I really wanted to have. And therefore, during my second year, I decided to keep on kind of exploring again the neuroscience path. And I did an exchange to UCLA where they had courses on neurophysics or biophysics that was kind of the first introduction for me to theoretical neuroscience and what I'm doing now. And I kind of fell in love with it and the fact that it was a much more applied science than the physics I was doing with the theory, and while still having this very much analytical approach. And so after doing this, and this year in LA, I also did an internship at EPFL, which kind of confirmed not only my interest, but also the will to do research in this field, and mostly research that is with a theoretical approach. And this is when I decided to then apply for my PhDs. And I realized that I think I applied at Gatsby, which is a program in 4 years that has a first year with courses. And I realized that was probably the best for me because I still felt that there was so much for me to discover in this field and also a lot of background in machine learning for me to get. And I was lucky enough to be accepted and start this first year, learn a lot about neuroscience and machine learning before really starting my research, which I've been starting now a year ago. In my third year of the whole program, and I'm working with Andrew Sachs and mostly focusing on learning dynamics and representation learning, both in the brain and in machine learning, with a very, very analytical approach, because I also it's just what I like to do on my day-to-day. I really like doing maths, and I really, I think artificial intelligence and the brain both suffer from the fact that we know it works, but we don't know how exactly, and really having an analytical approach to them and understanding what makes them work with, looking inside with very simple toy problems is really where I want to, where my research is, kind of based.
Wow, that's so impressive. Wow. And I really liked how you mentioned how neuroscience and machine learning, they're both similar in the way that they are kind of, they're so vast and they're so broad. And you've got to go through so many layers just to kind of get a good understanding, a good insight into those fields. And it's interesting to know how data and IT kind of fit in with fields that you wouldn't really expect, not really the typical fields of just general IT or finance, but you've also got fields that are very vital to human well-being, like neuroscience. So I think that's a really important point that you made. And I really do align with that. So kind of delving into your research at UCL further, could you explain to our listeners in simple terms, to those who might not really know what neuroscience or machine learning are, and kind of how both of these spheres fit into data science?
Yeah, so I like to say that I study mechanism of intelligence, maybe learning, memory, any kind of intelligent mechanisms using an analytical approach to mathematics. And I think this goes both for artificial intelligence and neuroscience, and then I think the data component aspect comes in many different ways within both of these fields. Either, for example, for neuroscience, a lot of data analysis is necessary when recording from the brain, and you get a lot of data and you need to make sense of it, and therefore a very advanced data analysis is necessary. And that's part of one of my projects where we used unsupervised method to find a process that's called replay in the brain. Replay is the idea that when you sleep, you will replay some of the things that you've done during the day to kind of consolidate them. And so by applying this new model, we were able to look at find replay in a new part of the brain and develop a new method to analyze it. So I think there's always a necessity to develop those new methods because we have more and more data in neuroscience. The methods to acquire the data is getting better and better. And therefore, this is, I think, one way to kind of apply vertical computational aspect to neuroscience. And I guess another way is to create models. So once you kind of have some theories from what you've measured and from analyzing the data, you can start building theories. And then there you can use machine learning and all sorts of models to be able to kind of try and get a deeper understanding on how it's functioning. And there, you use all of the types of models such as the Hopfield models, for example, or any even linear networks. And I think now it's very common to always add a component of theory to your understanding of the brain. And I think then if you go all the way towards machine learning, even like separating from the brain and trying to understand those mechanisms, I think in your previous episode, you probably have talked about it, but there's so many ways where I think there's many levels on which we can work. We can try to create new architecture, create new models, or like find new ways to deal with this huge amount of data that we have in different and novel ways. And I think my research spans a lot of these kind of levels of approach of theory and application of machine learning. And I personally finding, that's also why I really like this field, is because it's very modular and you feel like you can like use it in many different ways.
Wow, you explained it so well. I feel like I could take a course in it now. But okay, so you mentioned that you were always kind of interested in physics and maths as well. So did you kind of have that moment of realization where you realized like this neuroscience is something that I want to pursue? Like, was there a specific moment or kind of any task or activity that you did, if you're comfortable with sharing?
No, of course. I think for me, so I was always very interested in the brain and had done like a project on memory when I was in high school. But I think for me, it was more of a disenchantment of physics in a way, more than anything else, because I think when you do theory in physics, there is a very high probability that you may be doing useless math in a way, where the math you develop or the theory you develop is working in theory, but it may take 50 to 70 years to be able to test it. And I think it's very hard for scientists to, it's not as exciting, I think, and it may be in neuroscience, because what I like in what I do is right now I can kind of develop some kind of theory, derive some equation, maybe 5 years later, someone will be able to kind of test my theory, create an experiment and measure and tell me this is wrong. You have a much like faster feedback loop that I didn't have in physics. And also I think something that really attracted me to neuroscience is the fact that it's a very interdisciplinary field where you have people from very different backgrounds, very different ideas, and it forces you, first of all, to like have a much more parallel types of interaction with everyone, because everyone can like really bring you a lot of knowledge, and it's a very more enriching, I think, field environment than I felt I had when I was in physics, where it's kind of a niche. There's very few people, it's very difficult, and everybody's from the same background and the same type of education. And I think it lacks some creativity in a way that you get from having just multiple people thinking about the same problem in a different way. And I think, that's why I think I still got to do theory, which is, I think, my main interest, in being able to do maths on, I think, still problems that are super fundamental and things that people have been thinking about for, I don't know, centuries. How does the brain work? Things like that, which is also common to physics and kind of what wakes me up in the morning, having a very deep, interesting question, while having like the sense that it's much faster in the loop, but also the sense that there's so much more to discover, so much faster, and that we are right now in the field of neuroscience in a place where we can measure so much better the data, so we can get access to so much more, much quicker. It's really a field that's like booming, and it's very exciting to be a scientist as part of that. And I think that's why I was really drawn to it.
Yeah, definitely. I think you mentioned that kind of machine learning and specifically technology within neuroscience is a very, very quickly advancing field right now. And what kind of purpose have you observed personally that you believe that machine learning brings to neuroscience research? And perhaps what are some of the technological challenges that you have faced recently? Essentially, kind of what more do you think needs to be done within technology to kind of fill in these gaps or fill in the problems?
For neuroscience, mostly. So, I mean, that speaks to my research, but to me is trying to have like some theoretical understanding of what's going on and have some interpretability of all of our methods. If it's not proper theoretical derivation of equations, trying to understand how these models work in general, because we use them to also explain the brain. And if we don't fully understand some of the mechanisms, to me, it's the question, what does it mean to really understand? And I think, to me, a real push on theory and trying to really get some momentum on the theory experimental loop is really crucial, because right now you mostly have theoretical labs and experimental labs, and it's hard to really get experimental labs to do our theories. And so I think we're really lucky in Andrew Sachs' lab, because we are now in the ability to start having our own experiments, but it's very rare. And I think really getting some momentum like we have in physics, that's something that physics, I think, has really successfully done, is that the theory has created the experiments and a good feedback loop to kind of modify your theory. And I think this is where science is the most pro-efficient. And I think right now, because neuroscience is also so new, it is theory is not like strong enough to be able to really inform in a way that physics has in some way. But I think that pushing more in that direction to be able to build really strong theories will allow to hopefully convince more experimentalists to test our theories and give us some feedback on how to modify them in a very standardized way, where it's not, it is a hard and difficult thing to get to do, because I think especially when you do something very analytical, it's very hard sometimes to relate it to the brain, and it may be very high level for now, but I personally strongly feel that this is the direction that we need to go in the long term, because even though the field is moving super fast, that works also for machine learning, is moving super fast, and I think that we can always come up with new clever ways of kind of engineering our new models. I think at some point this may come to kind of an end, and we will need some understanding on how they work to be able to really improve their performances deeply.
Yeah, definitely. So if we kind of expand on what you said before, if you could take like a crystal ball, let's say, and predict how you see neuroscience research changing in the future, what is something that you kind of predict or you think would happen?
That's a hard question. I'm not too sure. I hope, I think that we have been having some success of theory and experiments, and I hope there will be more. And by that, I'm speaking about mostly like the success with the navigation system in the fly, where the theory is really well matching the experiments, and thanks to having access mostly to the connectomics of the fly. But obviously, it's a very, very small animal and a very small network. But I hope to see some more of those, maybe in for other tasks and slightly larger networks. I think that's reasonable.
Yeah. Wow. Very interesting. Very interesting. So, I guess for our listeners who are personally interested in undertaking a PhD, what does a PhD entail, first of all? Could you give us an overview of your degree and your research topic and how you relate it to data science, and maybe some of the skills that you think listeners should kind of brush up on before they start their PhD or undertake a PhD?
Yeah, definitely. So I think a PhD in at least the field I'm in necessitates a lot of mathematical background and computational background, a lot of abilities to be able to work on your own, get your own resources, and also I think something that I've learned is also know how to ask somewhat for help, not help, but advice from people around you, and know where to find the resources for you to help yourself when stuck, because it is a very, it can be a very lonely work, but I think science is also something that should be very collaborative, and most of the projects I actually have been doing have been very collaborative, because I think this is where they move the fastest, they are the most engaging and the most fun to do, and I would definitely advise someone to do as much collaborations as they could, obviously, with setting in place the right rules and the right expectations for collaboration within the group. And I would say, I would say you have to really be somewhat also quite passionate about what you're doing, because you're going to spend a lot of time studying it, but I think it's very rewarding. And one of the things I think also I've learned the most is lone work, working on my own organization in general, like knowing how to plan and find my own opportunities. But most of all, I've realized how important it is to present your work in a certain way. So your writing skills are extremely important in writing your papers, presenting your ideas. It's something, this is how you're going to convince people of your research, and this is something that's necessarily need to be done for reviewers. And that's something I think for me was the hardest. Writing is not my forte, especially it's not my first language, but I think this is something that is sometimes left out, but knowing how to, because you often do research and you have like a lot of results, but trying to create a cohesive story that you can kind of really present to someone is something that is truly important, especially to get your paper accepted, I would say. But it's very important, the writing skills and presentation skills.
Thank you so much. Those were really insightful points that you brought up that I'm sure would be really beneficial for a lot of listeners. So kind of sidetracking, I looked at your profile and you mentioned that you took an internship, a summer internship at CERN. Yeah. How did that go for you? How did you kind of approach that? And what did you learn from it? What activities did you do within that internship?
Yeah, so this internship was with the Alpha collaboration at CERN. So it's a collaboration that builds anti-hydrogen to be able to study the differences between matter and antimatter. And this is to figure out why in the universe there is more matter, there's this matter and matter imbalance. And the idea is that if you study closely enough the properties of antimatter, maybe you will see where the symmetry breaking was. And so I arrived there after my first year in physics. So everything was very new to me, but I helped on the day-to-day of the experiments. So I would run the experiment, and I actually we had this competition of how many anti-hydrogen you can catch, which is just running the machine, but you get lucky. And for a while I had the crown of the most numbers of anti-hydrogen, which is a ridiculous number compared to what they can do right now. But I think it was like 80, 90 anti-hydrogen. And now I think they can get up to 500. So yeah, that's what I was doing, trying to run with different settings the experiments to catch as many anti-hydrogen as possible, on which then they can do some laser analysis mostly. And so that was the first internship. I also helped to kind of build circuits, do a lot of soldering, and that was also a lot of night work, because the way it works at CERN is you only get you have 3 experiments that wants the antiprotons, and it runs all the time, and so it's separated in 3 slots. And so I got to work sometimes from 11 to 7 a.m. Trying to run the experiments, maybe also keep the magnets cool, adding some azote and things like that. So it was like really a day-to-day kind of keeping the experiment alive and building some circuits to be added in the experiment. And I guess through the programs, other things I've done was be able to give some tours and follow some lectures. And finally, I think I spent a second summer there where I started to design a new circuit. And the circuit was made so that whenever there's electric power cut in CERN, you don't want your magnet to, so yeah, the place where they keep the anti-hydrogen to cool down. Otherwise, if it cools down, then it can explode. So you need another source of electricity to make sure everything doesn't explode. So I was just making the circuit, the security circuit, to be make sure that this was not happening. Obviously, it's been checked by someone else. But yeah, I think I'm quite happy to say some of the circuits I've soldered, and this circuit is within the experiment. And finally, this led on to do my master thesis with them still, where I worked on modeling process, which is called the e-kick. So to cool down to make your anti-hydrogen, you need to first cool down your antiprotons very low. And to do that, you use electrons, which will take away the energy of your antiprotons. And then you need to get rid of them. And so it's a process where you need to lower down your magnetic field to let the electrons out, but not too much to keep your antiprotons in. So we did a model to kind of study the different ways we could do that. And yeah, I think it was quite a successful model. I'm not sure it's been implemented experimentally as a result. I know the person I was working with, I think, is still working with them now as a PhD. So I suspect maybe they've been carrying out this experiment. But from what I gather, now they are trying actually to measure gravity with antimatter because it's never been done. Expectation is that it should fall. The antimatter should fall like with respect to gravity in the same direction. But because we don't know and it's never been measured, maybe it will go up, who knows. But yeah, this is the new experiments they are really trying to lead right now.
Wow, that's very impressive. It's very impressive. And forgive me if I'm wrong, but you did implement some kind of computational programming, didn't you? You were able to kind of explore a bit of programming on the side at that internship.
Yeah,
Could
so
you
that
give
was
us a
part
bit
of
more about
my master thesis. So the model was like a peak model, and so yeah, it was really reproducing what was happening in the experiment with different plasmas interacting within electric magnetic field that you recreate to be able to understand the interaction and how to create anti-hydrogen. So yeah, that was mostly my master thesis that you can definitely find as well. I think I've put it somewhere online.
Definitely. Please do, listeners, check out her master's thesis if you are very interested. It all sounds like very interesting work and very necessary and very groundbreaking as well. So well done, thank you. But I guess to kind of end on an end note, do you have any last comments for budding data scientists listening in today, or for our kind of more general audience? Are there any resources that you kind of listen to regularly, or you recommend listeners to check out? Any influential people, or just kind of anything that you've read recently that has been really insightful to you?
Personally, I was just actually right before that listening to the Uberman Lab podcast. I think this is mostly about neuroscience. I think it's quite a good podcast around neuroscience. And I think it's trying to make science more accessible. And I think that's quite great if you're just generally interested in neuroscience. I listen to a lot of other podcasts, but there's the, I don't remember the name. Maybe, yeah, I'm really bad with names. Maybe I won't go there, but definitely I think podcast is a good way to easily get into some fields. And otherwise, I think in terms of like some tips in general, I would just say just reach out to people. I think this is what for me has created the most of my opportunities. And I've just always sent emails, talked to people, and just networking, I think, is extremely important. And I think this is something that is much more taught to business people who pursue business, let's say in uni, how to network. And I don't feel like something that I've been taught so much as doing physics or data science on how important that is. But I think this is what has personally got me the best opportunities. This is how I got my internship at CERN. This is how I got to know about the program, about my PhD. Someone advised it to me just by talking to them. I personally try to really answer as many people as I can and give the advice I can. I think people are more reachable, even though very busy. You also have to forgive people for not answering you because everyone's very busy. But definitely reach out and don't be scared to just have a leap of faith and try, put yourself out there for anything you want to try.
Definitely. I definitely agree with that. So how do you because a PhD is not easy at all to pursue, how do you kind of find the time to balance these opportunities and then also networking and then also kind of looking for your own resources? How do you do it?
I'm quite a hyperactive person. I love doing a lot at the same time. But I think for me, I in terms of my working hours, I really try to stick to some like normal working hours and making time for myself. And when I think, first of all, this is the first thing, really try to separate work and other activities. But also consider the activities of looking for resources, etc., as work, because this is work for you. And so I take it within the time of the PhD because, looking for, let's say, summer schools or things like that, this is part of your PhD, and I consider it as work. And I think the last one, kind of technique that I would use is I kind of change tasks as soon as I do the things I want to do. And if something excites me, I will do it. And I have many things to do. And I just switch tasks if I don't want to do the task I have to do. And hopefully I will find the time to do the other one. So I think having for me, having multiple things allows me to keep the interest in a way, to continue.
Thank you so much. Thank you so much for being our second guest as well, Clementine. Thank you for giving up your time to kind of talk to us about your interests and also how data science fits in with a vast array of fields that kind of wouldn't really be expected or be the typical field. I'm going to hand over to my co-host, Grace, for any last comments and last questions. Thank you so much.
Thank you for the amazing conversation, Hamna and Clementine. And also thank you for our listeners for tuning in. So please feel free to contact and connect with Clementine. Like perhaps you share a similar interest, or if you're looking to pursue a PhD in a related field, like she said, networking is very important. Like don't be shy to connect with her. So, and be sure to check out also our Instagram at ucl.datasci for further events and updates. Finally, we hope you to join us and tune in next time. So thank you for listening and thank you for the wonderful conversation, and see you next time. Until next time, Bits and Geeks.